Hello everyone! Today we will finish up chapter 4 with how are trigonometric functions applied. Part 1 will cover some stuff that you already know, angle of elevation and angle of depression. You should already kind of know that from the past. Angle of elevation, just remember, always touches the ground, okay? And angle of depression always touches the sky. So you'll see what I mean when I start sketching it. Let's read this problem together. At a point 200 feet from the base of a building, the angle of elevation to the bottom of the spire is 35 degrees. And the angle of elevation to the top is 53 degrees. Draw a correct diagram to represent the situation, then find the height of the spire. Anytime you have a situational problem, just don't be scared of it. Always make it real, okay? So I've drawn the sketch for you. I know I'm such a good artist, and we're gonna actually fit that drawing with what's given here, okay? So at a point 200 feet from, oh, sorry about the spelling error here, from the base of a building, the angle of elevation is, okay, to the bottom of the spire. Remember, I don't know if you guys know what a spire is, but spire is this part right here, okay? That's a spire. That's like an antenna, right? Okay? All right, so let's actually sketch that. So it says from 200 feet from the base of the base, so 200 feet, okay? From the base of the building, the angle of elevation, remember angle of elevation always touches the ground, to the bottom of the spire, okay? Bottom of the spire, let's label that sucker, 35 degrees. Okay, let's label it, okay? All right, now it says, and the angle of elevation to the top is 53. Oh, okay. So that means I have another to the top of the spire from the same point, 200 feet, right? And I'm going to sketch that angle really big here, and that's 53 degrees. All right. Look at that sketch. All right. All right. I'm sure now you can imagine two right triangles that are formed, right? Because the building is a right triangle here. Because this, if you imagine this building as this wall right here. All right. Draw a correct diagram, which we did, to represent the situation, then find the height of the spire. So let's do this together. I'm going to write it in steps, okay? So we've labeled everything from this problem situation, and we're going to do this together now, okay? So I think it really helps is if you draw two separate triangles, two separate right triangles. Here's one like this, where it's 35 degrees, right? And this is the height of the building, right? I think that should help you. And this is 200 feet. Another one is a little taller, right? And it's 200 feet, and it's 53 degrees, right? And it's going to be the height plus the spire. What do you want to label this? Oh, you know what? Let's do this, you guys. Let's label this sucker as X, okay? As X, the height of the building. And then let's actually label the spire as H, and then the building is X, right? So this is going to be X plus H, okay? Let's do it that way. So then the height is what we're looking for because they want to know the height of the spire. Height of the spire, okay? All right, let's keep going. All right, now, okay, let's actually write two expressions or equations with what you know here, okay? So that's the first thing. Let's write it with this one. This is a right triangle. This is a right triangle. So we all know that we can use what? Tangent, right? So tangent, because you're given the opposite and you wanna know the opposite, you have the adjacent. So tangent of, sorry about this drawing, okay? Tangent of 35 degrees is opposite over adjacent. So you know x is equal to 200 times tangent of 35 degrees. Let's write the other equation with the spire. Okay, so tangent of 53 degrees in this case, right, is equal to opposite over adjacent again. So it's going to be x plus h is equal to 200 tan 53 degrees. Notice I don't actually calculate them right away, okay, even though we're excited to. I'll tell you why later, okay? Okay, so we've done that already. Okay, but what do we want to know? What we want to know is actually the h, right? Okay, but we have to find x first. So let's do that, okay? Well, I'm sure you've noticed that we can find the x here, okay? So also another thing we notice is this. Okay. Okay, they both have an x involved, so we know we can calculate the x. So you know what, let's go ahead and do that. So let's get our calculators. Make sure you're in degree mode since we're in degree mode. So we're going to go to documents. I always work with the document. So one, new document. Say no, I don't want to save that. But make sure you're in the, let's actually make sure that we're in the correct mode. So we need to make sure that we're in document settings, degree mode. So we are in degree mode. It says right there, okay? So I'm going to go make default. Always make default. All right. Okay, we're ready to jingle. So x equals 200. Oops. Let's go back to the document. New document. Oh, sorry about that. Okay, let's go to document. Open, new document. No. And I want to add a calculator, okay? So 200 times tangent. You can literally write TAN if you wanted to, 35 degrees. And I know I'm in degree mode, so I'm going to do it like this. And I'm going to get the approximate value, which is about that. Okay, I'm not going to write that down, but instead, I'm going to actually store that value. So we know that x is about 140.042, okay? But I'm actually not going to do anything with it. I'm actually going to store this sucker. So I'm going to store, blue, right? So we're going to go control, store, and I'm going to go like this, okay? And I'm going to call that guy. Just kidding. Let's erase that. I'm going to go to store. Oops. How do I get the blue again? Oh, sorry about that, chicos. So you have to go like this and get this value, scroll up to it, and then go to store. Sorry about that. And I'm going to call that guy what? I'm going to call it X. Why am I going to call that X? Because that is what it is. So we want to keep consistent with our actual problem. So I'm going to call that as X. All right? So we've done that. So anytime I need an X, I'm going to actually plug it in. Okay? All right, let's go back now to step 3. Okay? Now we also know that 200 tangent 53 degrees is equal to x plus h, right? So let's go here. 200 tangent 53 degrees is equal to x plus h. But we know that x value, right? So let's subtract that. So that means 200 tangent of 53 degrees minus x is h. So we're going to calculate that. But we're not going to calculate it multiple times. We're just going to do it in once, right? So it's going to be 200 times tangent 53 degrees. Let's actually enter that first, okay? Minus x. But I'm going to either scroll up to the x, I want to scroll up to the x, or I'm just going to call an x, minus x. And it's dark x because they already know that we've already stored that variable. So I get something like this. So I got that h is approximately 125, and notice my calculator is already in fixed 3, okay? 0.367 feet high. Just a couple of things to notice. I guess this was step 2, but this is step 2. I guess a couple of things to notice is notice the number of times that I inputted my calculator, the estimation. I never calculated this, right, at beginning, and I never used the rounded values. I always use the stored values, or I scroll back up to the original values, all right? That's what you get here.